Continue with the side group. Okay, if the bulky side group present at the main structure, it can hinder bond rotation more than the smaller one, and therefore cause the increase in the TG because the bond had to rotate. Also, the polar groups such as chlorine, CN, or OH have the strongest effect. See in the table, they have poly and vinyl carbazole with transition temperature 200 something compared to PP and polystyrene because of the presence of the benzene ring and nitrate group here. Hence, increase the TG. So this benzene ring and also the nitrate structure will prevent the bond to rotate. Hence, increase the TG. Compared to this structure that contain OR, if you compare with the structure that contain benzene ring, this structure is more flexible, and the tendency of the chain bond or the side group to rotate is higher compared to the structure that contains side group such as benzene ring. And if the high flexibility the chain, it will reduce the TG. Oxygen add flexibility to the chain. Okay. So if the oxygen presents at the side group, it will promote the flexibility. Okay, next, free volume. Volume is a small amount of unfilled volume is associated with the end of a polymer chain. So this volume is called the free volume. If we have high free volume in the structure of the polymer, it will reduce the TG. Basically, short chain will have high chain end and will contain more free volume. TG for shorter chain lower than TG for long chain. Why? Because shorter chain it has more chain end per unit volume, so there will be more free volume. Note that the shorter chain polymer also has more free volume frozen in below TG than the long chain polymer. So if you don't want to get confused, you can create your own mind map. Okay, awak kena buat mind map supaya awak boleh nampak the factors that affecting TG. When the TG low, what happened, and when the TG high, what will increase. Okay, so that you can see the overview of the factors affecting TG. Here's the branching. Okay, polymer with more branching have more chain end, so it will have more free volume, which reduce the TG. Okay, remember that if the polymer have high free volume, it will reduce the TG, but it depends on the structure of the branch polymer. Okay, so if the large side group attached to the main polymer, it will increase the TG. So that's why it depends on the side group of the polymer attached to that branching. Okay. So if the large side group attached, it will hinder the rotation, hence will increase the TG. So which of this effect is greater depends on the polymer in question, but TG may rise or fall. Because a compact branch side group generally lead to a stiffening of the polymer chain and create an increase in the melting temperature because of the effect that have been explained before. And in terms of the cross-linking, okay, for the polymer that have highly cross-linking, it will reduce the chain mobility and will increase the TG. It also affects the microscopic viscosity of the polymer, since if there are crosslinks between the chain, then they are fixed relative to each other. so will not be able to slide past each other. The effect of molecular weight. Low molecular weight chain have more N per unit volume than long chain, thus a higher free volume, hence a lower Tg. Means that if the high molecular weight polymer, it will has less chain N and less free volume, hence it will increase the Tg. Practically, the glass transition temperature value of a polymer is influenced by the molecule weight up to 20,000. Beyond this limit, no appreciable effect is seen. As we can see here, Tg for polyalpha methylstyrene is the largest, and it has the 3.6 times 10 to the power of 5. Dia punya apa nama? Molecular weight dia lah. Okay. So we can see that as the Tg increase, the molecular weight will increase. Next is the diluents and copolymerization. Plasticizer added to polymer to improve its flexibility and processability. And low molecular weight additive will increase the free volume of the system, thus lower the Tg, allowing for rubbery properties at lower temperature. Hence, high diluent will increase the free volume and will decrease the glass transition temperature. Because increase in the rubbery region, it makes the structure in the molecule easily move and will increase the chain mobility. This one is the structure for unplasticized PVC, and this one is the structure in the presence of plasticizer. So in the presence of the plasticizer, the circle one here is a free volume created in between the structure, hence make the polymer easily move. Hence we increase the Tg, increase the mobility, and we reduce the Tg. Okay, in terms, another factor is the random copolymer has lower Tg than homopolymer. And in terms of the polarity, if the polarity of the polymer increase, the Tg also increase because of the intermolecular forces increase, and it will increase the strength of the polymer. Alright, the crystalline melting temperature Tm. Further increase in temperature provide more energy to the molecule and the polymer will not melt. And the temperature at which the molecule transition from rubbery state to a melt state is called the melt temperature. And factors affecting Tm is the same factors that affect Tg. Usually, high Tg and high Tm are found together. If Tg increase, Tm also increase. And high polarity and hydrogen bonding will increase the melting temperature. Basically, the molecular symmetry leads to high melting temperature. For example, Pe has high Tm due to tightly packed crystal, although Tg is low due to the flexibility of the chain. Okay, this one is the thermal property of polymer examined by the DSC instrument. This one is the glass transition temperature, which is kita ambil nilai dia at the midpoint in the inclined section. And this one is the TC, okay, crystallization peak, give an exotherm peak. And this one is the melting temperature at 339. Show an endothermic reaction, which is absorb heat. So basically, we determine the enthalpy or degree of crystallinity by using differential scanning chrometry. And the melting of a crystalline polymer and the glass transition Tg are example of the thermal transition that can be measured by using DSC. Of course, it has a sample pan and the reference pan. The reference pan is for the we leave it blank, and the sample we put it in the sample pan, and the sample will be heated at the heating rate, which is 2 degrees C and above, and the result and the graph will be appeared in the monitor. This device consists of two pans. In one pan, the polymer sample is loaded and the other pan is left empty. And the computer assembly will turn on the heaters and the heating rates of the two pans and accurately control about 10 degrees C per minute. And the computer programmed the heating rate to stay exactly the same throughout the experiment. And it is also important to note that the two separate pans with their heaters are heated at the same rate as each other. And the presence of polymer material in the sample pan results in an uptake of more heat in order to keep the temperature of the sample pan increasing at the same rate as a reference pan. And the amount of heat it takes to get a certain temperature increase in a material is called heat capacity, or CP. And heat capacity is obtained by dividing the heat supplied by the temperature increases. Therefore, DSC plot gives a CP value. And TG value is a value which is in the midpoint here, TC and TM. It must follow TG, TC, and TM. So it is important to recognize that not all polymer will show TC and TM. Okay, TM and TC will show up for polymer that can form crystal, and the completely amorphous polymer will exhibit only TG. However, polymers with both crystalline and amorphous domain will show all the features as shown above. For polymer that amorphous, it will only show a TG value. That's all.